is a relationship which is called Euler relationship? Why is this connected? So in the Euler relationship is E power g theta is equal to cosine theta plus j sine theta, while E power minus j theta is cosine theta minus j sine theta. How we get this? Actually, this relationship, try to find it. It's basically you need to write e power g theta in a form of Maclaurin series. Okay, so you're gonna end up with cosine theta plus g sine theta. If you write it in the form of Maclaurin series, you end up with this form. Okay. Now, so what is the exponential form? Now, you know the polar form of complex number we discussed that last week, which was z equals to r cosine theta plus j sine theta. But we know that e power g theta from the Euler formula or Euler relationship is cosine theta plus j sine theta. Of course, again, if you want to find the derivation for any textbook, you find the derivation. It's quite long derivation because gonna do a Maclaurin series for e j theta, and you're gonna end up, and if you do the Maclaurin series cosine theta times j sine theta, you end up with the same. Now, and that you end up with z equals to r e j theta. So this is your exponential form of a complex number. Example. If you have a complex number z equals to 3 plus 3j, now write z in exponential form. Need to write it in exponential form. So to write in exponential form, r need to be identified, and theta, which is the argument, need to be identified again, correct? So you end up with r to identify which is modulus of the complex number. And if you remember, it's a square plus b square, correct? And a square is simply 3 square plus b square, which is 3 square, which is square root of 18. Okay? Now we find the modulus r. We need to find theta with the argument. To find theta, we need first to find alpha. We said it's tan minus 1 b over a. This is the problem with the connection. Sorry, it's okay with you? It's like flashing sometime? It's okay? It's not. So a and b, it has to be in absolute values. Tan minus 1, a is 3 over b is 3, b over a, sorry. So will be tan minus 1 is equal to, just to let you know, when you use exponential form, theta must be in radian, okay? So you will have pi over 4. Okay, pi over 4. Now this is alpha, so but we need to find theta. That theta depends on the location of which quadrant is a complex number. So you need to find out which quadrant. This is real domain and this is imaginary domain. Now a and b is somewhere, this is a3 and b3, so the complex number z in a first quadrant, correct? So it's a first quadrant, therefore your alpha equals to theta equals to, so it will be pi over 4, correct? So the complex number z is written r ej theta equals to square root of 18 e power j theta, which is j pi over 4, and that's it. Okay? Questions? Okay, clean up. Now we need to do some operation on a complex number. Which is multiplication and division. Oh, so. Okay? Multiplication and division of a complex number. If you have a complex number z1 is r1 e power g theta 1. And another complex number Z2 is R2 EJ theta 2. Now, multiplication of Z1 times Z2, if you think about it, Z1 is R1 e power G theta 1. Z2 is R2 e power J theta 2. Now R1 and R2 can be multiplied. Now EJ theta 1 times E pi J theta 2. So you end up with Z1 times Z2. It's simply R1 times R2 e power. We have EJ theta 1 times EJ theta 2. So we're gonna sum up the powers. So you will end up with J theta 1 plus theta 2. Correct? Similarly, if we need to do the division, now if Z1 over Z2 and Z1 is R1 e power G theta 1 and Z2 R2 e power G theta 2. So R1 over R2 e power, now we have e power G theta 1 and e power G theta 2, so we subtract the powers because we're dividing e J theta 1 over e J theta 2, so by dividing, therefore we need to subtract the powers. So J theta 1 minus theta 2, and that's finally if you want to divide theta 1 from theta 2. Z1 over Z2. So in exponential form, okay? So in your exam, make sure you read the question. So if I give you two complex numbers, I told you divide these two complex numbers, Z1 over Z2, in exponential form. Don't divide them in different form. I ask you to do it in exponential form. Now, finally, based on a multiplication, so what you can say that Z power n will be simply R power n e power G n theta. Okay? Okay? Example. Example. If you have a complex number Z equals to 1 plus 8J. Write it in, first question is, write Z in exponential form. B, find Z power 11. Okay? Now to write it in exponential form, you need to find r, which is the modulus of z, which is square of a square plus b square. It's the square root of 1 square plus 8 square, which is square root of 64. Okay? Now you need to find the argument. You need to find alpha, which is tangent minus 1 b over a. Now your tangent minus 1, your b is 8, and you take them in absolute value, in positive value, over 1, it's 1.45 radian. So that tangent is radian, okay? Now, you find alpha, and you need to find theta, and theta depends on the location of the complex number within the 2D domain, which means it's in which quadrant. That complex number, it seems, is that is the real values and that is imaginary values. So the real value is 1, while imaginary value is plus 8. So it seems a complex number in the first quadrant. In the quadrant number 1. It's in the first quadrant, correct? Since it's a complex number in the first quadrant, therefore your theta it equals to alpha, which is 1.45 radian. And then what you can say, you find theta and you find r, and just to let you know that theta has to be a radian in here. Therefore your complex number is in exponential form is r ej theta, which is square root of 65 e power 1.45 j. Correct? Now to find z power 11, it's simply you power r, which is square root of 65 to power 11, as we said here, n is 11 here, yeah? Times e power gn theta, j times 11 times 1.45, which is 65, 11 e power 15, 95 j. Okay? So when complex number 0, so if you have a complex number z is equal to a plus bj, in order to make z equals to 0 complex number, this is only if a equals to 0 and b equals to 0. Therefore, your complex number is 0. It's not only a0 or b0. No, both a and b. Okay? So that's the way that complex number is 0. So for example, if you have a complex number, again, z equals to a plus bj, that give that a equals to 0 and b equals to 0. So that's the way when complex number are 0. So if a equals to 0 and b equals to 0, so z equals to 0, a plus bj equals to 0, and vice versa. Now equal to complex number. Or equal complex number. So assume you have a two complex number, a plus bj equals to c plus gj. When these two complex numbers are equals, when these two complex numbers, a plus bj and c plus dj, when these complex numbers are equals, what a condition? The only condition if a equals to c and b equals to d, correct? These two complex numbers equals only if a equals to c and b equals to d. So the imaginary numbers are equals and real number equals. So basically if we said a equals to c, this is the real part, and b equals to d, this is imaginary part. Okay, so once the real parts equals and imaginary part equals, so the complex number is equals. Okay. Give an example. So before what we said, find 3 minus 2j over 5 plus j in the form a plus bj. Okay? Now, dividing two complex numbers in Cartesian form. Do you remember? What we have to do? We multiply. This is the first method. We multiply numerator and denominator by the conjugate of the denominator, correct? So what we said, 3 minus 2j over 5 plus j. I will multiply numerator and denominator by the conjugate of the denominator. 5 plus minus j, which is a conjugate for the complex number of the denominator. Because the conjugates 5 plus j and 5 minus j. And 5 minus j. And you remember the conjugate, basically you change the sign of the imaginary part only. So for example, 5 plus j is the imaginary part here is plus 1. So to have the conjugate is, you said 5 minus j. You change the sign. Now, let's remove the brackets. So you will have 3 times 5 is 15. 3 times minus j is minus 3j. Minus 2j times 5 is minus 10j. Minus 2j times minus j is plus 2j squared. Over, if multiplied two conjugates, is you said 5, it's a squared plus b squared. Do you remember that? We had first class. It's 5 square plus 1 minus 1 or 1 square. Now what you have here, j square, if you remember that j square written equals to minus 1, correct? Agree? So you will have minus 1 times 2, it's minus 2 plus 15 is 13. Now minus 3j minus 10j is minus 13j over 5 squared 25 and minus 1 squared is 1, is 26. Or 1 over 2 minus 1 over 2j. Correct? That's the way we have done it before and straightforward, correct? Or there is another method. So what we said, first of all, for the first one, that is a plus bj, okay, at the end, that we write it in the form is a plus bj, yeah? Or another way is, I will say 3 minus 2j over 5 plus j. I'm looking for to write it in a form a plus bj, correct? My aim is to find a and b. Now, by doing the cross multiplication, so what is in the denominator of a plus bj is 1, yeah? Cross multiplication, so 3 minus 2j times 1. You know what the cross multiplication is, yeah? Huh? No? Yes or no? You know what I mean by cross multiplication? This was last semester. So if we said 3 over 6 is 1 over 2. The cross multiplication means that 3 times 2 equals to 1 times 6. So this equals to, equivalent to, 3 times 2 equals to 6 times 1. That's cross multiplication. Okay? The same here, if you said 6 over 2 is 3. And the cross multiplication means the denominator of 3 is 1. Because 3 over 1 is 3. So 6 times 1 equals to 3 times 2. Okay? The same thing here. 3 minus 2j times 1 equals to a plus bj times 5 plus j. Correct? Correct? So, 3 minus 2j equals, not remove the bracket over there. It is a times 5 is 5a. A times j is 5a plus j times a. bj times 5 is 5bj. bj times j is bj square. That gives us 3 minus 2j equals to 5a plus ga plus 5ag minus b. Yeah, why? because j squared is minus 1. How can I continue here? So you will have... I'm going to continue up here. So you will have 3 minus 2j equals 2. So you have a real number, which is 5a. We have another real number, which is minus b. I'm gonna put the real numbers together, real parts together, and the imaginary part, which is ja and 5bj. I will take j outside. Correct? Now, we have two complex numbers, 3 minus 2j and the other complex number. And we said when these two complex numbers equals, when the imaginary parts are equals and real parts are equals. Yeah? Correct? So what is the imaginary, where the real parts here? Is 3. The real part must be equal to the other real part, which is 5a minus b. And the imaginary part is 2 minus 2 must be equal to the imaginary part for the complex numbers. It's minus 2 here, must be equal to the imaginary part here, which is a plus 5b. I will not carry on for solving. Solving these equations, you end up with a equals to 1 over 2 and b equals to minus 1 over 2, which is exactly what we find from the method 1. So your a and b, so your 3 minus 2j over 5 plus j will be equals to a plus bj, which is 1 over 2, minus b, which is 1 over 2j. And that's the solution.